Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning to everyone. Alright, so welcome to weekly sharing session, a short webinar series organized by Renew. So first of all, on behalf of Biomechanical and Clinical Engineering Research Interest Group, so I would like to express our appreciation to Renew, okay, for giving us this short opportunity for us to share a little bit on our research activities in BioMeC. All right, okay, so before we go any further, so let me share with you a brief introduction on agenda for today's webinar. So we're going to start with introductory remark by moderator. Then our first agenda is going to be introduction of BioMeC by Professor IRTS Dr. Haji Solehuddin Shuib. Then we go to the first presenter, okay, Associate Professor TS Dr. Fazli Abdul Manan. He's going to share with us on the research journey in skin biomechanics, design and development of Bisector Rinn holder for oral X-ray. Then we proceed with the second presenter, the second speaker, which is Professor IRTS Dr. Haji Solehuddin Shuib. He's going to share with us on development of knee implant using additive manufacturing technology. Then finally, we go to discussion, question and answer, and then future works and collaboration by both panels. And finally, the concluding remark by the moderator. Okay, so I think it would be good for me to share the goals, the objective of this short webinar. So of course, we want to share our research activities in biomechanical and clinical engineering with all warga UiTM. Okay, and then the second, we want to promote the academic discussion for research community building. All right, so with that, I would like to go ahead by call upon Professor TS Dr. Solehuddin Shuib to introduce, to make an introduction of biomechanical and clinical engineering research group. So please welcome Prof. Soleh.
Thank you, Dr. Afzan. Can you allow me to share the screen?
Yep.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much, Dr. Afzan, for chairing the session. Thank you, Renew, for very good effort to organize this kind of sharing session. This kind of sharing session should be promoted because our theme of the university is synergy. So one of it is synergy because we would like to synergize among our ourselves and then among our research group that we have at our university. And then from there, inshallah, we can, can plan for bigger effort, bigger grant at national and international level. For this first agenda, I just would like to share about what biomechanical engineering group is all about. BioMeC. It is basically a short form of biomechanical and clinical engineering group. The short form of it is BioMeC. It has been established back in 2016. To be exact, 11 October 2016. And I know we just started. We are still new, but inshallah, we start to grow small, bit by bit, and alhamdulillah, right now we have achieved to become RG, inshallah. And then we plan to proceed further, to expand further. This is our team member. We have a permanent team member headed by Associate Professor Dr. Abdul Halim, okay, and then Prof. Jamal, we call Prof. J, our previous leader, previous head, and myself, and we have here Dr. Fazli, Dr. Afzan, and Dr. Nur Azmi. And we also have our associate member, Dr. Muhammad Fairuz Azmi. We have Dr. Kasalia and Dr. Nurul Haiza, and also Dr. Shahrul Hisham Marwan from UiTM Perdana. Basically, BioMeC, what we are planning, or our niche and relevant of biomechanics, basically we have outlined three important aspects, or three important niche. One of it is to encourage multidisciplinary research on mechanical engineering and medical physics. That is our first niche, or our first objective of our BioMeC. And number two, we organize, or we involve testing, research activity which involve testing, analytical equation, modeling, computer simulation, and to develop medical support prototype and components. Okay, and then last but not least is to integrate the perspective of applied mechanics and material science to solve practical and biomechanical problems, okay, based on clinical experiences and industrial demand. These are many activities that we have, okay, at present, okay, on the starting from development of new design, okay, of medical support component. We do synthesis, processing, fabrication, okay, machining, testing, okay, and modeling of engineering material, okay, and medical support component, and also to integrate engineering design and potential medical application. Basically, we just came back from radiology department recently of UiTM to, they have proposed us to solve a few of related problem, and then we try to assist or to help them to solve their problem, and then knowledge and technology transfer to researcher and client, including the guideline, software, problem solving, and innovation of the design. Okay, so these are our team members, their CV. I don't want to elaborate more about this one. I think I stop here. Back to you, Dr. Afzan, to proceed with our agenda. Thank you very much.
All right, thank you, Prof. Solehuddin, for the brief introduction on BioMeC. So I would like to proceed our agenda by introducing our first speaker. Okay, hold on. Okay, Associate Professor Dr. Nur Fazli Abdul Manan. Okay, so he obtained his PhD degree in Mechanical Engineering from Universiti Tanjung Mara, UiTM, in 2016. Master of Engineering in Mechanical Engineering, Universiti Kebangsaan Malaysia in 2007, and Bachelor's of Engineering in Mechanical Engineering from the University of Manchester in 2005. So his research area is in biomechanics, composite, design process, and failure analysis. So Dr. Fazli has officially served for UiTM as a lecturer since 2007, and he is currently a coordinator for engineering mechanics and material at the College of Engineering COE, UiTM Shah Alam. So he has been lecturing various undergraduate courses such as mechanical engineering design, dynamics, statics, and also vibration. And currently he is supervising 3 postgraduate students in the area of biomechanics and failure analysis. So he has published more than 26 journal papers with international publishers since 2016. Until 2021, the total citation were up to 150 citations. So his expertise and experience has led him to win several innovation awards from local and international bodies. So with that, I would like to let Dr. Fazli to take it away. So please, Dr. Fazli.
Okay, thank you, Dr. Afzan. Allow me to share my slide. Okay, Bismillahirrahmanirrahim. Assalamualaikum and very good morning for everyone. Okay, my name is Nur Fazli Manan. All right. First of all, thank you, Mr. Chairman, Dr. Afzan, and also Prof. Saleh for introduction. Okay. Before I begin details on the research work, all right. I wish to share some my journey of in biomechanics. Okay, the work started since 2012, which is during my PhD. I work on the skin, on the animal skin. Okay, I characterize the skin properties to identify any potential to use in computational analysis. Okay, after graduated my PhD, I collaborate with Faculty of Dentistry, okay, led by Prof. Yusmaidil. Okay, during that time, Prof. Yusmaidil introduced some problem facing in radiography or X-ray, okay, because he wants of the expert in radiography orthodontic, which is on oral dentistry. Okay, so we collaborate to design a new Rinn holder to assist in medical oral X-ray. Okay. In 2018, my first postgraduate student started work on healing patch for the skin. Okay, that is my current work. And then we know in 2020, the pandemic come for the whole world, and then no experimental work able to proceed. So I and my team and also postgraduate student moved to computational analysis work on the analyzing using computer aided. Okay, and now 2022, still working on the skin biomechanics. Okay, so I believe what I did on skin biomechanics shows about beginning of the research work, but not until the clinical. So the clinical work that has been tested now on the design of the print holder. Okay, therefore, my topic of the presentation about design and development of this multiple angle print holder. Okay, which is involved on mechanical parts and some with the clinical works from dentistry faculty. All right, these are the problem that has been brought up to us in the first 2016. Okay, in the beginning, Dr. Yusmaidil explained to me about this details on the Rinn holder, that normal Rinn holder that available in the market, And this Rinn holder are medical device used to perform an X-ray for your teeth. Therefore, the colors represent in the Rinn holder shows has its own specific function. For example, on your right side, left side, or in the middle, okay, from the front. All right, and the problem at that time, Dr. Yus explained that current device unable to be used for a patient with a low palate. If they use that device, the image of this X-ray would be distorted and didn't show a specific hole or any flaws on the teeth. So that caused difficulties in perform a next task. In other problem, there's two types of technique, which is paralleling technique and also bisecting technique, normally used in medical X-ray. And then the work sometime for imaging will be repetitive. That means needs to be take for a few times for the X-ray. So from that problem we identified, to come up with a new design of this Rinn holder. Okay, so basically I'm utilize this mechanical design approach or the mechanical design methodology, okay, starting with conceptual phase and then proceed with the embodiment on the modeling, okay. We ensure that the model or new product follows specific as needs for anthropometric or agronomic data. Okay, after that, once the clear on the product model, we perform an analysis, okay, computational analysis to consider the strength of the product. And then once it shows a very good performance, we proceed for the prototype, which is the future works. That means the next work is a clinical test. Okay. So this the process of product model. Okay, started by creating 3D models in CATIA version 5, okay, as I showed in the methodologies. And then every part we create individually, okay, to make sure that it's able to be produced towards the end. Okay. And then we proceed with the analysis as I mentioned before. Okay, analyze if any functionality of and the movement of the product is able to be made. And then when it shows a good performance, we prepare the product using 3D printer. Okay, that shows some how the product has been prepared through the 3D printer. Okay, so after that we clean up that thing, prepare part by part, and we perform the assembly. And to the end, it's prepare the prototype of the product. Get my slide start. Okay, this shows some analysis that has been performed after the product has been received. As I mentioned previously, the stress and displacement analysis has been simulated computationally, and then clinical work has been done by the expert of the dental, which is from team of Dr. Ismail. And we look into the tolerance and the effectiveness of the design holder. Okay, we can the slide shows about the conventional and the design, the new design Rinn holder. It shows on the tolerance of pain. We investigate on the moderate pain or mild pains on the patient, and then on the effectiveness, which we look in details about how many numbers of image should be take during the X-ray. Okay, so in general, it shows only one process, and also the tolerance shows more of patient having no pain instead of mild pain compared than previous holder. Okay, this I would like to explain about the development of the Rinn holder. It's not only one single design. Okay, in the 2015, we developed with angle. Okay, with angle. If you can have a look from the blue and white Rinn holder on top of the picture, we just put the incline holder. Okay, for capture the bisecting technique for this holder. Okay. Then on the 2018, this Rinn holder move further. Okay, we designed it able, instead of one fixed angle at that moment, now it's able to be inclined in few angles, depends on the teeth of the patient. Okay, however, it's manually, which is we need to open the slot and lock it in the angle. However, the recent one, I and my team designed with only one touch, you can tilt the angle as needed for the X-ray. Okay, that shows the development. All right. So for me, with this product design development, it gave us few things achievement. Okay, few achievements, which is we won a few awards from the iTech Silver and the iTech School, and also with a Diamond Award in 2018. And with this project also, we managed to get two publication. Okay, two publication and few undergraduate student project has been completed. And then using this product development, we managed to get one PPRN grant worth 96,000, and then we managed to get copyright, and also coming soon our patent lead by Prof use for this product. Okay. Right, this would be future works lah. Whereas I hope clinical tests should be involved, and the involvement should come from the medical expert. So if any collaboration, we can discuss with dentistry team. Okay, and then we also hope we can produce this holder with a what we call it, biodegradable material. So we really need people from in what we call Faculty Sains Gunaan might be to involve to get a right material to use in this project. And we plan also to embed some sensors in the product So might be those from computer science can join this project later on. Or we hope from the mathematic faculties, expert for nonlinear can join us to characterize some equation. This specific for my skin project lah. Right? Okay, that's all for this moment. Thank you. Back to Dr. Afzan.
All right. Okay. Thank you, Dr. Fazli, for the very interesting and inspiring presentation and sharing. All right. So for those who have questions, so we're going to have the question and answer session at the last part of our webinar series. Okay. So, but if you have questions, so you can type those in a chat box. Okay. So I will read through the question and address to our speakers. Okay. All right. So without further ado, I would like to proceed with the second speaker. Okay, so I think it would be nice to get to know with our second speaker. Let me introduce Professor Solehuddin. Okay, so Professor IRTS Dr. Solehuddin Shuib. So he has been working for more than 20 years with academia. In terms of teaching, he has taught 20 different subjects and conducted design classes and labs. So his teaching benchmark can be seen through a good student evaluation at the end of each semester with rating more than 80%. Okay, so he have graduated 4 PhD and 4 master student. Okay, at the same time, he has supervised more than 100 final year student projects. For research and publications, he has successfully placed him as a reputable researcher. Okay, so he has been considered to be one of the leading researchers in biomechanics, especially on bone metal implant. For this research works, he has obtained number of national grants as main and co-researcher, worth more than 2 million. His research of international and national standing has been further supported by more than 140 international journals, publications, and proceedings. He have filed 5 intellectual property, IP, in the form of copyright and patent. Okay, so his consultancy services have earned a good reputation as well. Okay, within the 20 years service with university, he had the opportunities to participate more than 10 consultancy works worth approximately 4.4 million. So besides bridging income to the university, he hoped this will bring closer relationship between university and industry. Okay, I think with that, I would like to call upon Professor Solehuddin to take it away. So please, Prof. Soleh.
Thank you, Dr. Afzan, for very kind word. Can you see the slide?
Yes.
Okay. Within a short period of time, I think I just would like to share one of our, our latest project related to the development of knee implant. Okay, we high flexion knee implant, also patient specific using additive manufacturing technology. Basically, this project very dear to our group member because we are talking about the cost of the implant is very expensive, and also when we talk about population in our region, most of our population in our region, we are Muslim and we are Muslim. Therefore, when people who undergo the surgery, they cannot or no longer can perform prayer as usual. So only when they want to perform prayer, they only can sitting on the chair. So this is the topic of our project, which is the customization of knee implant. Okay, with high flexion. through additive manufacturing technology. I am the group leader of the project, and we have our team member. Okay, we have Dr. Halim over there. Okay, wearing a cap, and then Dr. Afzan. Okay, and then we have our latest professor, Prof Hussein. Okay, and we have Prof Fairuz, orthopedic surgeon. And the project also, we have industrial collaborator, okay, who always help us, okay, in terms of the technology, okay, to do the fabrication, and with metal 3D printing, which is Dr. Izhar Aziz. He is CEO of 3D Gens and Berhad. And also I have another orthopedic surgeon from USM. I've been working with him since 2006. It's Prof. Amran. Prof. Amran Ahmad Shukri, orthopedic surgeon from Universiti Science Malaysia. Okay, next slide is related to the market study. About market study. At least we know a bit about the product that we want to develop. At least we know in terms of the demand. Because sometimes when we develop something, the demand is very low. But for this one, when we refer to the number of orthopedic patients in Malaysia recorded, we have about 1 million in 2017. The total 200,000 patients that perform operation under elective or emergency operation. If 1% of operation require a total knee implant with the average price of $4,500 which is equivalent to nearly 20,000. Okay, so the estimated market value of total knee implant will be 30 is about that figure. Okay, so in addition of that, there is a growing number of patients with osteoporosis. Okay, and this one also is expected to propel the total of knee replacement industry growth positively. And then last but not least, we are talking about our aging population. Okay, by 2035, 15% of the Malaysian population, their age will be 65 and old. Okay. I just proceed to explain about our project, okay, of a high flexion patient specific knee implant. This is the role of UiTM, and the role of our collaborator. Our niche at UiTM, basically, for example, we talk about BioMeC. We can do the consolidation of the product development. Okay, that is our niche. Material selection, we can do testing, we can do finite element analysis. Okay, and also we have also our niche, as I mentioned just now, is in terms of metallic material. Okay, we have with about generative design. Okay, and manufacturing process. And then for UiTM side, okay, for our medical faculty, we have our collaborator, which with Prof Fairuz. He can help us in terms of the validation of our end product, testing using cadaver, and then before we can, put the implant to the patient. Okay, and then for 3D Gen, they have the expertise in terms of a complete digital workflow. Okay, from when we get the CT scan data, we have start from CT scan until the production of the implant. Okay, complete digital workflow on surgical procedure. Okay, for the fabricated implant. For this case, we have fabricated of high flexion patient specific total knee replacement. Okay, and then same role by Prof Amran at USM, because we need to get the acceptance of our surgeon, top surgeon, because at the end of the day, when we produce our implant, which has been validated, and then we have went through all of the requirement. At the end of the day, the one who will use the product is the surgeon. So the acceptance of the surgeon is very important, and they need to to be involved in the project from the early stage of the project. Okay, I have mentioned about this one. My project, basically our dream, our target is basically we want to produce our own total knee implant, kan? Hip implant, knee implant for lower limb. But for this one, I'm talking about high flexion implant, okay, which can flex, up to 155. I attended one conference recently, World Congress Biomechanical, when there is a sharing session from researcher from Indonesia. They also have developed about the same thing, but they can fly up to 153, okay, up 153. But we have achieved, or we have obtained the angle up to 155, okay. This is, when you look at this figure, we start with the following figure. You can see this figure. We have implant reconstruction, which is the implant design. Then from there, the implant, we have pre-processing, and then manufacturing. We have after that post-processing and medical post-treatment. These are the cycle that we're going to do again and again, hip implant, knee implant, ankle implant, or any other implant, okay. But what happened over here, these are the issue. We have, at present, there is what we call a traditional surgical procedure, okay, which is still based on manual fitting, okay, in situ surgical planning, okay, with standard implant sizes and shape, okay. So when manual and standard implant system was used, it will affect the longevity of the implant, okay. So therefore, what we need over here is we need what we call design customization. Okay, design customization. Okay. And also, as I mentioned just now, the issue of the price. Okay, most of our implant, they are important. Okay, so I think this is high time for us to have our own product. Taiwan also recently they have their own, they have produced their own implant. Indonesia, they're working towards that. I think for our country, I think high time for us to produce our own. You look at over here the product, the cost of TKR product in the market, Zimmer, you have the price, implant price, primary implant from top different companies. Zimmer, the cost is 9K, Stryker, Johnson and Johnson. This is not patient specific, but this is the price of the implants available. Okay. Okay, I just proceed about our project. Our project, we have fully produced the high flexion implant. Okay, so what we are trying to promote over here is the digital workflow, and also the implant itself, which has these three components. We have femoral component, we have tibial component, and we also have the insert over here. So this is our previous work that, regarding this project. Basically, this project we have started quite some time, and then our last PRGS project, we have successfully developed high flexion TKR implant, which can flex up to 155, and then it has been fabricated, okay, and has been tested, okay. I have sent the sample to Endo Lab in Germany to do a series of testing to check in terms of high flexion, in terms of fatigue test, okay. And Alhamdulillah, recently we also developed our own testing. We have developed our testing G, okay. We developed, and then we have last week, Alhamdulillah, we have tested knee and hip implant, okay, using our own facility, in our own facilities, okay. These are the previous work that been done, the design, the analysis, okay, and also we have done a few benchmarking, proof of concept, okay, started in 2013 basically, okay, 2013 until recently, alhamdulillah, we have I have secured a PRGS grant, and then we have completed the grant, and then these are the output of the grant of PRGS grant that I have closed this year. The impact of the project that we have last time is basically we have successfully obtained the tested prototype of high flexion, okay, using metal 3D printing, and then spin off from that we have we have file IP, okay, have file IP, and our way forward right now is to apply my lab grant for further testing, for certification, and also to do testing using cadaver, and also to install it to the patient, to the patient. I would like to share our a video of the project. Second. Okay. That. The Afzan, let me stop sharing and then I share the video.
Okay, Prof.
Okay, let me see. Where's the video? Number 2. Okay, share video. Share audio. Okay. Can you see it, Dr. Afzan?
Not yet, Prof. Yeah, you are sharing. Okay, right.
Can you see
Yes,
anything?
if it is not on screen, you just hear the audio.
Okay, hold on. Let me do it. Do the adjustment. Yesterday I have tested this one. Stop share again. Okay, here you go. Okay, this is related to the existing problem while we are doing the project. Okay, and then this is the starting from problem and discussion how to do improvement. Okay, what software is part of the design that we are going to complicate and testing. This is in terms of series of implant design. Bukan try sekali terus jadi. We are trying different design based on the skeletal design. This is the prototype that involve using regular material, and then we do the printing using metal 3D printing. design different type of material that we use. Okay, and then after that we do design improvement. Okay, the design that we have produced, we have sent to Germany, and then initially it's broken at the C shape tu kan. Belum apa lagi dia dah broken, tapi after that we did further improvement, and alhamdulillah was very successfully done and been tested. Okay. And this is the final design. Okay, the final design. Of course, after it get printed using 3D printing ni, dia really further treatment lah, further treatment so that the surface, roughness of it, dia akan become smooth, in like the one that's available in the market. Okay, this is the final design that we printed. So meaning that our solution start from pre-planning, CT scan tu sampai we successfully produce. Okay, stop here. So I continue my slide. How many minutes left, Dr. Afzan? 1 minute.
About 1 minute, 2 minutes.
Okay. Very quick. This is very quick.
It's okay, bro.
Okay. Okay. Macam tadilah I have mentioned just now. Like Dr. Fazli lah. Actually, I tak aim lah semua benda-benda ni kan. Benda ni kemudian kan, award, apa semua paper yang tu dia will come later. Because macam prototype grant ni dia tak bagi kita hantar public paper, dia tak bagi duit pun. Kan, yang dia nak IP saja. Jadi saya pun tak fikir sangat that one. Cuma kita fikir how to make this one happen kan. Jadi at the end of the day we have our own high precision implant or any implant. Jadi siapa researcher yang nak buat later on, the flow will be the same. It's the same like this one. We start with the what we call the digital workflow, and then after that you have you need to study the design of it. You do the design, reverse engineering kan, and then you buat analysis, and then you produce, you do testing kan, macam itulah. And you have to engage. You must engage with the medical team. Itu mesti ya. Sebab baru ni I have attended one lecture given by President of Mayo Lab. He talked about the same thing. Dia kata at one time they have a lot of money, and then at one stage stagnant because the product that they develop is not relevant, no user. The orthopedics, the surgeon or the medical practitioner that they did not accept it. And jadi buat apa design orang tak guna kan, macam itulah. This is the methodology. Macam tadi saya tak mau elaborate more about it. This is certificate of filing, okay, and then the output of the project. Maknanya output dia customized. That's your selling point, customized, patient specific implant, and then number 2 is in term of digital workflow. Yeah. So dua tu lah kita punya novelty. So as I mentioned, expected IP tu customized implant, and then the digital workflow. Okay, apa impact dah? What will be the impact? Impact dah come out in terms of economic contribution, kan? We'll create new business, we'll create new IP and others lah. I don't want to elaborate more. Thank you very much. I think that's all, Dr. Afzan, from me. Back to you. Thank you.
Okay, thanks a lot, Prof. Soleh, for the nice and very interesting presentation. Okay, so I think we have done with the 2 presentation by our 2 speakers. So I would like to open up this session for question and answer. So for those who have question, you can type those question on the chat box. If any, ada ke soalan?
They can ask live also if they want, no problem.
Yeah, can Nur Haiza. So please.
Assalamualaikum warahmatullahi Sorry tak ubah background. Just a quick question untuk Prof Soleh. Thank you very much Dr. Fazli and Prof Soleh. It was a fantastic sharing, walaupun singkat. Banyak belajar. I'm just curious actually pasal the knee implant. So in terms of because you're studying the best for flexion, right? In terms of integrating it with the bone, what type of material do you use and how do you do the integration? Is my curious question.
Actually, we didn't develop any new material. We are using the existing material. Okay. Maknanya yang being accepted by the one that being used by by the industry lah. We have ada stainless steel, ada titanium, ada cobalt chromium, and then dia punya insert tu yang tu lah dia Afzan apa polyethylene PE kan, PE.
Yeah, ultra high molecular
Ultra
weight.
high. Cuma cerita pasal way forward ni lah kan. We are talking about dia punya lattice structure interaction. Sekarang ni yang tu the area is coming up. When I came back from Taiwan virtually bukan physically, bila way forward given by president of ISB from Italy, these are the important aspect yang kita boleh further research lah, which is in term of the interaction tu, interaction kan, tissue interaction, dia benda-benda tu lah. Ingat Dr. Haiza boleh pick up benda ni lah, insyaAllah boleh tulis Q1, Q2 paper ni kalau yang berkait dengan benda ni.
Itulah sebab because tadi Prof Soleh you mentioned nak buat test using cadavers kan, so I'm like I'm just curious lah how it actually merge together because sometimes
cadaver ni kita tengok dari segi dia punya mobility je. Mobility nak tengok okey tak okey, yang tu Prof Hairus lah, he will do the test kan. Kita dah order dah cadaver, itulah doa lah kalau ada rezeki insyaAllah UiTM kita nak pergi defend my lab dalam waktu terdekat ni. Kita minta dalam 3 million, doa-doa lah kalau ada rezeki dapat, jadi kita boleh test kat cadaver dan terus pasang kat patient macam tu.
Okay, thank you Prof. Tu je my question. Thank you.
Okay, macam tu lah.
Thank you, Haiza.
Assalamualaikum Prof. Apa khabar?
Oh, Prof John, how are you?
Oh, fine.
Assalamualaikum.
Prof, saya nak tanya sikit lah dalam biomedic ni.
Ini
Prof pakai
Syam
Haji Syam.
Okay.
Jadi boleh introduce kot?
Okay, Prof kenal. Prof, saya nak belajar sikit lah dari segi biomedic ni. Prof guna finite element to reduce the cost before working prototype kan. Jadi accuracy di antara finite element dengan experimental result tu berapa persen Prof kalau dalam bidang biomedic ni? Kalau bidang operation ni kami tahu lah at least 5% kan.
Okay, sebenarnya untuk apa yang finite element ni, dia tak boleh sama macam yang industri lah, sebab ini antara isu yang semua researcher dalam finite element. Sebab kalau dalam WIBOR kan kita nak buat berapa persen you punya experimental work dengan simulation kan. Jadi memang simulation yang dibuat tu dia dah tengok dia punya stress distribution saja kan. Jadi gap antara eksperimen dengan simulation tu, kalau you kata nak target yang macam kalau bidang contohnya dalam industri, for example macam kita buat stress analysis kan, kita nak compare kan. Jadi ada yang percentage dia very small kan, kadang ada yang less than 1% pun ada lah. Tapi yang ni kalau eksperimen dengan simulation ni dia can go up to 10 to 15% Dr. Syam.
Oh, jadi walaupun within that range we can use the finite element to subsequent analysis ke apa? Itu lah. No problem lah dalam bidang biomedic.
Selalu kita guna stochastic approach lah. Statistical approach lah.
Okey. Terima kasih Prof. Dan soalan kedua saya kepada Dr. Fazli. Tadi Dr. Fazli dah mention tentang non-linear equation. So, what does it mean non-linear equation actually? Because usually memang kita involve dengan non-linear kan, dalam anything pun memang ada non-linear. Either we not consider non-linear ataupun we really want to consider non-linear. So, boleh tak detail out sikit Dr. Fazli?
Okay, terima kasih Dr. Syam. Okay, yang tadi saya masukkan untuk non-linear tadi, more on apa nama tu, hyperelastic equation lah. Okay, yang untuk skin normally kita nampak dia dah tak boleh pakai apa stress and strain punya deformation. So kita dah go through ke hyperelastic. So dalam hyperelastic normally model yang digunakan adalah apa? What we call non-linear tadi lah, which is dia ada very apa nama tu complex equation kat situ. Jadi itu yang equation yang itulah kita involve apa integratekan dalam apa untuk eksperimen ataupun numerical yang kita consider lah. Normally yang saya punya involvement tadi normally pada skin punya biomechanics je lah.
Saya rasa yang untuk Dr. Fazli bila involve memang skin memang dia banyak pelajar ataupun researcher dia banyak dia guna model yang isotropik kan, linear elastik kan. Jadi yang tu level project lah kot kan, ataupun level untuk final project lah. Tapi bila nak go to real tu we are talking about anisotropik tau, anisotropik dan sebagainya, tu satu. Kemudian yang kalau skin ni dia ada pakai apa Moni-Rivlin punya equation, kemudian dia ada pakai apa Dr. Fazli yang you guna tu?
Ordin model.
Ordin model. Jadi benda-benda tu sebenarnya dia perlukan banyak data kan, eksperimen data dan sebagainya. Jadi and involve also nak kena libat financial dan sebagainya. Jadi satu lagi yang takut malam-malam kan, libat cadaver kita pun jenis takut juga kan nak buat dan sebagainya. Jadi kita kena beranilah akan datang dan kalau benda yang melibatkan benda-benda yang macam tu.
Okey, terima kasih Prof Soleh dan Dr. Fazli.
Thank you for a very good question. Okey, pasal yang Dr. Fazli sebut tadi, I think kita share ni sebenarnya kita bukan kata our project ni will stop here. Dr. Syam tanya tadi tu sebenarnya dia ada kepakaran dia yang dia nak offer. Saya nampak macam tu lah. Sama juga dengan yang lain tadi kan. Sebenarnya kalau you ask me lah, I be involved with biomechanical project ni for the last, I think for the last I have started since 2003 kan. Jadi kalau yang baru-baru nak buat tu saya ingat ada benda-benda yang saya rasa yang kalau boleh shortcut kita boleh shortcut kan. Jadi dari segi learning curve tu kita boleh potong kan. Jadi apa benda yang nak buat dan sebagainya. Macam saya sebut tadi ada dua benda yang sekarang ni with the latest technology yang kita ada kepakaran kan. Kemudian banyaknya kita work in silo. Tu masalahnya kan. Jadi for example biomechanical sebenarnya we have our own niche. Kemudian problem from medical we get involved, let them involved kan. I know they are very busy, tapi we ask, we meet them, we tanya bila dia orang free and then we discuss with them, kemudian balik kita buatlah, dia orang mana ada masa kan. Kawan-kawan kita sebab kita from medical faculty, from faculty of dentistry, they are very busy kan. Tu satu. Number two, kalau kita nak bagi jauh lagi ke depan, nak bagi maknanya ada impact lagi. Number two ialah in term of macam Dr. Fazli sebut tadi, kena libatkan juga kawan-kawan kita daripada Faculty of Mathematics and Computer Science. Jadi they can help us in term of mathematical modeling. Germany, they are very good in this. Kan? Germany. Kemudian baru ni Stanford University pun they are very good in. Dia benda-benda yang macam ni. Kan? Jadi kita kena top up benda tu satu. Kemudian yang satu lagi ialah in term of the involvement of the industry. Dalam kes dia, I think I'm very lucky lah, alhamdulillah kan. We have a very good support kan, from industry, and then they ada problem we discuss kan, Jadi it is what we call sampai ada MOU kan. Kita ada grant, dapat grant sekali, kemudian nak apply grant, further grant. Mula grant kecil-kecil lah, dan kita slowly kita build up. Dan itulah yang akhir sekali ni macam saya sebut tadi lah. yang apa benda-benda yang lain tu dia akan datang kemudian lah, kan. IP kemudian dari segi nak jual akan datang kan, berapa persen dan sebagainya, tu kita ada involve lawyer lah dan sebagainya kan, yang tu UiTM punya lawyer office lah, dia akan bantu kan. Tapi nak set up maknanya flow dia benda macam tu. Jadi siapa yang baru nak mula, contoh saya cakap tadi, banyak lagi area ni yang boleh dikembangkan kan. Sebab seorang tak boleh buat semua kan. Lower limb ni saja ada hip, ada knee kan. Kemudian yang Prof Hussein dia duk fokus pasal gigi kan. Cerita pasal dental implant ni memang tak habis juga kan. Banyak design dia, material issue dia. Kemudian sikit lagi yang pasal apa lagi? Ankle. Kalau tengok anything yang berkait dengan spare part for human body, maknanya kalau ada seorang yang dedicated buat, saya rasa insya-Allah dalam masa yang terdekat you all boleh capai benda-benda yang mana yang kita dah buat sekian lama ni kan. Sekian itu saja daripada saya. Dr. Afzan.
Right, thank you Prof Soleh for the answer. Okay lah, one last question Prof and Dr. Fazli from me. So how do you see the future of localized development of what we call it, the medical device? Because if I take the scenario in Japan itself, so even their local manufacturer also leave behind. The surgeons still prefer the abroad manufacturers such as Zimmer and what you call it, Stryker for their implants.
Okay.
So what is your comment, Prof? 1 minute.
Okey, saya dah sebut tadi. Sebenarnya balik kepada kita punya ni lah. Dari segi kemampuan kita kan. Kemampuan kita dah develop, kemudian acceptance daripada surgeon, kemudian surgeon dah pasang to the patient, dah berjaya, dan setakat ni kita dah pasang kan, dah berjaya pasang dan tak ada masalah kan. Tapi kalau you nak develop new material, dia punya jalan tu lagi panjang kan, panjang ceritanya. Tapi kalau if you are using the established punya material kan, cuma you ubah design dia dan sebagainya, kemudian you protect dia punya design tu dengan ada IP dan sebagainya. Jangan cepat-cepat nak masuk IIDA ke apa semua. Jadi kita dah dedahkan our design tu, kita punya trade secret kita tu kat orang cepat-cepat. Jadi menang gua syok, tapi orang dah tiru kita. Yang tak protect kan. Jadi ada baik buruk dia lah dan sebagainya. Jadi kita kena ada, macam saya sebut tadi lah, ada 3 komponen tu. Saya sebut tadi keyword dia 3 komponen itulah. Digital, kemudian personal, kemudian kita kena ada sinergi 3 perkara tadi. Way forward.
Alright, okay, thanks Prof for the answer. Okay, so I think that is all for
Dr.
today's
Afzan,
yeah. Dr.
Can I
John.
chip in? Just one question, Prof Soleh.
Yeah, can.
Okay.
Okay, it's okay. No problem.
Okay, it's okay.
Stochastics, you talk about stochastic. Stochastic ni actually involved dengan experiments and then also the meta models. And then the problem when we try to correlate with the statisticals and the experiments leads to hard convergence and ill conditions. So macam mana normally dalam case Prof Soleh medics ni, how to improve or to correlate this model actually?
Okay, dia pertama sekali sebenarnya kalau dalam keynote saya dah bagi itu kat Japan berkait dengan apa kajian for the last 40 years menggunakan numerical method kan. Maknanya kita dah buat kajian this area for the last 40 years kan. Jadi saya share lah, sebenarnya bukan saya buat tapi saya hasil daripada paper-paper yang ada, jadi saya present lah benda ni kan. Jadi macam tadi itu isu dia ni way forward lah ni. How to improve the sensitivity of the available modeling tool kan, isu dia yang tu. Jadi kalau dalam konteks this area ni maknanya improvement in the study design lah. Study design through implementation of statistical method kan. Jadi bila sebut statistical method tu namely probabilistic analysis lah. Jadi kita akan tengok dua benda lah. Satu dari segi patient variability kan. And another one adalah dari segi implant positioning. Kan? Jadi dua tu lah. Kan? Itu yang saya nampak yang boleh tengok lah. Jadi ringkas dia maknanya kena faham lah dari segi the understanding the behavior of the total joint punya replacement, and then barulah pergi kepada decision support tool kan untuk planning orthopedic surgery. Itulah sikit Dr. John.
Okay, Prof, last question boleh tak? Saya nak tahu ni boleh tak? UiTM ni, Prof, supposed to position UiTM ni ke dalam to fundamental ataupun real application ke macam mana? Ataupun 30-70 in biomedic ni, Prof. Saya tertarik dengan Dr. Kita punya Mr. Chairman tadi ada tanya tentang localization.
Localization.
So interesting. But the issue where we supposed to position ourselves, but really into fundamental or
Ya, sebenarnya Dr. Syam, saya pun baru kita peringkat nasional ni kita ada wujudkan we just form a task force lah, okay, headed by Datuk Rafiq UiTM. Baru ni I also the committee member untuk kita nak draft blueprint national blueprint of biomechanic lah kan. Sebab what happen over here, everybody they are working in silo satu kan. Number two, macam ada saya tengok the work in silo. Jadi because work in silo tu dia dapatlah gerak runcit-runcit dan macam tu je. Tapi at the end of the day, it didn't give any impact pun kan. Not giving any impact kepada to the country in term of maknanya kita nak having our own locally produced implant dan sebagainya kan. Jadi that's why we have taken that initiative. Maknanya we have done a series of meeting, and then after that insyaallah lah bila set blueprint tu kita akan bring forward to the ministry, to the ministry yang berkaitan, and then insyaallah lah kita tengok ada perubahan. Harapnya adalah kan macam mana blueprint untuk area-area yang lain lah kan. Itu satu. Mana kami dah buat lah, maknanya ada Prof Azwan, ada Datuk Rafiq, kemudian saya sendiri, kemudian adalah yang key player in the area yang kita dah buat series of meeting. Even pangkat UiTM pun saya rasa kita nak kena sit down juga kan. Saya nampak banyak yang buat ada yang macam-macam kan, motion capture Dr. Afzan. Kita ada mesin tu dan sebagainya, tapi saya tak tahu setakat mana perkembangan. Jadi masing-masing buat kan dan sebagainya, kita tidak sinergi kan. Jadi sebagaimana universiti promote sinergi, jadi saya ingat kita lah we are the one nak kena sinergis dulu among ourselves, and then baru kita pergi ke pangkat nasional dalam bentuk kekuatan, satu force yang kita ada something.
Okay, Prof Soleh, excellent. Saya doa supaya sukses.
InsyaAllah, terima kasih. Thank you very much.
Okay, so I think we can stop, right? Our webinar session this morning. So thank you so much once again to Renew TNCPI for giving us this opportunity to share a little bit of our research activities under BioMeC. Okay, and thank you also to all audience. Okay, so that is all from us. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
And have a nice day.
Kamu tengok gambar sikit ke?
Gambar ke? Okay, boleh.
Bukti.
Okay.
Fazli dah cakap elok lah.
Boleh buka kamera masing-masing.
Boleh kena ni. So jangan malu-malu lah datang jumpa grup kita, Dr. Halim ketua kami kan. Jadi
ya, kita ada Dr. Halim ketua.
Bolehlah jumpa dia kan. Saya bukan ketua kan, saya ikut dia aja.
Ya. So kita memang welcome lah kalau siapa-siapa nak collaborate dengan BioMeC.
Ya.
Please welcome. Okay, yang lain? Sekejap Alright. Okay. Sekejap Satu lagi ke? Nak buka kamera? Dr. John, please. Dr. Hisham. Okay. Okay, cantik lah Dr. John. Dr. Cham mana? Tak ada. Okay. 1, 2, 3. Sat. Okay.
Okay.
Okay, kejap. Satu lagi. Freestyle. Okay. 1. Silap button ke? 1, 2, 3. Alright.
Okay, Alhamdulillah. Thank you
Okay.
very much.
Okay, thank you so much. Thanks to all.
Okay, thank you, Dr. Fazli.
Yes,
and the team.
Excellent session.
Thank you. Assalamualaikum.